Hi friends, in this video we will discuss the simple harmonic motion, of course, as a projection of uniform circular motion. Yes, we know that simple harmonic motion is that kind of periodic motion. Of course, it is a kind of an oscillator motion in which the restoring force is directly proportional to the displacement, but the restoring force is always acts towards the mean position. Restoring force is directly proportional to the displacement. Restoring force is directly proportional to the displacement. But always acts towards the mean position. But always acts towards the mean position, or equilibrium position అని కూడా అనుకోవచ్చండి. mean position or equilibrium position, mean position or equilibrium position, right? See, the restoring force అనేది, we know that restoring force, especially in the simple harmonic motion, restoring force is always acts towards the mean position, because the restoring force will try to keep the body in the equilibrium state. See, just in case of an spring mass system, you know that spring mass system చూస్తే స్ప్రింగ్ మనం ఎక్స్టెండ్ చేసామనుకోండి, లెట్ us suppose this is the mean position or the equilibrium position. సో స్ప్రింగ్ మనం ఎక్స్టెండ్ చేసామనుకోండి, స్ట్రెస్ చేసామనుకోండి, the restoring force or the spring force under that will acts in opposite direction to keep this mass into its equilibrium position. Similarly, in the simple harmonic motion also, this restoring force or the equilibrium force, this restoring force is directly proportional to the displacement but acts in opposite direction. Kabatti we can use this empirical relation, right? And we know that force equals to mass into acceleration, since the mass is constant for a given body. And of course, we can also say the acceleration of a body is directly proportional to the displacement and also acts towards the mean position, or directly proportional to TC equals to directly proportional TC constant of proportionality usual, and we can use acceleration is equals to minus of omega square into y, where the square of omega can be considered as a constant of proportionality in this case. This is what the angular velocity, constant of proportionality, right? Anyway, our intention in this video is to discuss how this simple harmonic motion can be considered as a projection of uniform circular motion. To understand this, we will try to take an example of a piston cylinder arrangement. అండి, ఒక piston cylinder arrangement just like in our IC engine, ఒక piston cylinder arrangement తీసుకొని we will try to understand, we will try to convert that as simple harmonic motion, right? So we know that simple harmonic motion, we know that the piston cylinder arrangement is also a best example of the simple harmonic motion, right? So piston cylinder arrangement, let us take a cylinder having a piston like this, right? ఈ cylinder of piston reciprocating అవుతుంది అనుకుందాం అండి between two dead centers, that is the inner top dead center or the inner dead center, just like this, and the outer dead center or the bottom dead center అనుకోవచ్చు. క్లియర్? సి పిస్టన్ అనేది ఈ టాప్ డెడ్ సెంటర్ నుంచి బాటమ్ డెడ్ సెంటర్కి reciprocating అయితే, we know that when the piston reaches the bottom dead center, its velocity becomes 0 and changes its position and moves towards the top dead center. When the piston reaches this top dead center, here also the velocity is 0, clear, and changes its direction. And మధ్యలో ఈ స్ట్రోక్ లెంత్, జస్ట్ the length between the top dead center and bottom dead center మనం stroke of length అనుకుంటే, and between the middle of the stroke length we can have one mean position. So we can have a mean position just like this. This could be considered as a mean position, right? So this is the one extreme position, this is another extreme position. Between this we have a mean position. Let us try to convert this as a uniform circular motion. Let us try to understand a particle which is executing a uniform circular motion. Uniform circular motion ante etandi? Rotational motion with constant angular velocity. If the motion, if any rotational motion having a constant angular velocity, that particular motion can be called as a uniform circular motion, right? Let us try to understand a particle executing a uniform circular motion. Of course, uniform circular motion antane it is having a constant angular velocity. Omega is constant in the circle. Clear? So we know that this is the mean position. This is one extreme position. In our case, this is the top dead center extreme position, and this is another extreme positions. So at these two extreme positions, the velocity of a particle is 0, but at the mean position, its velocity is maximum. Clear? And acceleration is opposite. Acceleration is 0 at the mean position, and of course, acceleration is 0 at the mean position, and of course, maximum at the extreme position that we know in case of a simple harmonic motion. Now, a particle or a body at a point O is rotating with a constant angular velocity. It means that a body is having a uniform circular motion. Let us try to understand this body. From this body moves from this point O to point P just like this. Clear? So point O నుంచి body point P కి మూవ్ అయింది అనుకుంటే, point O నుంచి body point P కి మూవ్ అయింది అనుకుంటే, so we can identify what is the displacement of this particle, right? So let us try to understand the amplitude, that is the maximum displacement from the mean position. So ఈ mean position నుంచి, this is what the mean position, right? This is what the mean position. ఈ mean position నుంచి extreme position ఉండే maximum displacement మనం ఏమనుకోవచ్చు అంటే amplitude అనుకోవచ్చండి. Here also this could be considered as an amplitude or the radius or amplitude of this particle. So particle యొక్క amplitude ఇది అనుకోవచ్చు, and point O నుంచి point P కి మూవ్ అయ్యేసరికి it's undergone some angular displacement, that is theta. Let us try to understand. So theta displace అయింది అనుకున్నాం, angular displace అయింది అనుకున్నాం. Clear? So now ఈ point O నుంచి point P కి body displacement y, vertical displacement y అనుకుంటే, so this y could be this distance, అంతే కదండి. ఈ y ఏమనుకోవచ్చు మనం, this y could be also this distance. ఈ y అవుతుంది కదా, this is the vertical displacement. Now let us start our discussion as the displacement of particle, the displacement of particle, of course from mean position. So displacement of particle ni y ఎలా ఫైండ్ అవుట్ చేయొచ్చండి, ఎలా ఫైండ్ అవుట్ చేయొచ్చు? వీ నో దట్ సైన్ థీటా యూజ్ చేసాం అనుకోండి, సైన్ థీటా ఈక్వల్స్ టు y by a, where a is the amplitude here. This is what the maximum displacement from the mean position, amplitude ante. So we can say that y equals to a sin theta, right? We can also read it as theta equals to, we can take it as angular velocity equals to theta by t. Clear? Angular velocity equals to theta by t, right? So theta can be considered as omega times of t, right? We can rewrite it as displacement of a particle at a given point P. Say at a point P, that is y equals to a sin omega t, amplitude times of sin omega t, of course in meters, right? See, ఒక పర్టికులర్ పాయింట్ P దగ్గర పార్టికల్ యొక్క డిస్ప్లేస్మెంట్ ఫైండ్ అవుట్ చేస్తే, we can also find out the velocity at a given point and of course the acceleration at a given particular point. So let us try to understand this as 1, we will write it as point 1 and point 2 as point 2. Let us try to understand the velocity of a particle at point P, of a particle at point P. So velocity v equals to dy by dt. Velocity is nothing but rate of change of displacement. Clear? So we know that d by dt and y, that is a sin omega t. Already మనం derive చేసి ఉంచాం. The displacement y equals to a sin omega t meters. Clear? సో దీని యొక్క ఫస్ట్ డెరివేటివ్, డిస్ప్లేస్మెంట్ యొక్క ఫస్ట్ డెరివేటివ్ మనం వెలాసిటీ అనుకుంటే వీ కెన్ రీవరైట్ ఇట్ యాజ్ amplitude is constant, derivative of sin omega t, that is cos omega t into derivative of omega t with respect to t, that is omega. Velocity at a given point we got it as a omega into cos omega t. This is one equation we got, of course meter per second. And inka ee equation short cheyochu mano, that is we know that a small observation, that is sin square theta plus cos square theta మనం 1 అనుకుంటే here cos theta we will get it as square root of 1 minus sin square theta. Similarly cos omega t ని ఎలా రాయొచ్చు అంటే square root of 1 minus sin square omega t. Clear? Square root of 1 minus sin omega t, that we got it as sin omega t, that is y by a. Here sin omega t ఎలా రాసుకోవచ్చండి, sin omega t equals to y by a, displacement by amplitude. So we can take sin square omega t, that is y square by a square. Therefore cos omega t we got it as 1 by a square root of a square minus omega square. Clear? So ఈ cos omega t ఇందులో సబ్స్టిట్యూట్ చేస్తే v is equals to a omega into 1 by a square root of a square minus y square. A will get cancelled. Velocity equals to omega times of square root of a square minus y square. This could be the formula for velocity of a particle at a given point p, meter per second. Any point దగ్గర, ఆ పాయింట్ దగ్గర ఉండే డిస్ప్లేస్మెంట్ అఫ్ కోర్స్ మనకు తెలుసు ఒమేగా ఇస్ ద కాన్స్టెంట్ ఇన్ దిస్ కేస్. సో యూనిఫామ్ సర్క్యులర్ మోషన్ కానీ ఒమేగా కాన్స్టెంట్ ఉండదు కదండి. సో ఆ పొజిషన్ దగ్గర మనకు డిస్ప్లేస్మెంట్ తెలిస్తే వీ కెన్ ఫైండ్ అవుట్ ద వెలాసిటీ ఆఫ్ at this particular displacement. Third important observation, similarly we can find out the acceleration of particle p, the acceleration of particle at a given point p, acceleration of particle at point p తీసుకుంటే, so acceleration ఎలా చెప్పుకోవచ్చు అంటే this is what the rate of change of velocity or the second derivative of displacement, right? So therefore a equals to d by dt, velocity we got it as a omega into cos omega t, a omega into derivative of cos omega t, that is minus sin omega t into omega. Therefore acceleration we got it as minus a omega square into sin omega t meter per second square as one formula. And we know that already మనం చూసాం sin omega t is nothing but displacement by amplitude. So sin omega t అంటే ఆల్రెడీ మనం చూసాం కదంటే y by a. So we can rewrite it as acceleration as minus a omega square into y by a will get cancelled, and acceleration of a particle at point p, that is as minus omega square into y. ఇది ఆల్రెడీ మనం చెప్పుకున్నాం. Simple harmonic motion is such a kind of motion in which the restoring force, say the acceleration, is directly proportional to the displacement and of course acts in opposite direction, and are directly proportional to తీసి ఒక కాన్స్టెంట్ ఆఫ్ ప్రపోర్షనాలిటీని మనం తీసుకోవచ్చు. దట్ ఈస్ వాట్ ద ఒమేగా స్క్వేర్ ఇస్ ద కాన్స్టెంట్ ఆఫ్ ప్రపోర్షనాలిటీ దట్ వీ హ్యావ్ ప్రూవ్డ్ నౌ. ఎస్పెషల్లీ ఈ త్రీ రిలేషన్స్, especially displacement of a particle and acceleration of a particle and velocity of a particle, ఈ త్రీ ఫార్ములాస్ ఒక్కసారి చూద్దామండి. ఎస్పెషల్లీ ఫ్రమ్ ద కాంపిటేటివ్ ఎగ్జామినేషన్ పాయింట్ ఆఫ్ వ్యూ ఈ కాన్సెప్ట్ మీద క్వశ్చన్స్ అయితే నెంబర్ ఆఫ్ క్వశ్చన్స్ అయితే ఫ్రేమ్ ఉన్నారండి. దట్ ఈస్ వాట్ ద డిస్ప్లేస్మెంట్ ఆఫ్ ఎ పార్టికల్, డిస్ప్లేస్మెంట్ ఆఫ్ ఎ పార్టికల్ అట్ ఎ పాయింట్ టీ ఎలా చెప్పుకోవచ్చండి, y is equals to a sin omega t, especially the velocity, second, that is velocity v at a given point is equals to omega times of square root of a square minus y square meter per second. Similarly third, that is acceleration a is equals to omega square minus times of omega square into y. Acceleration is equals to minus times of omega square into y meter per second square. These three formulas especially are very important from the competitive examination point of view, and especially ఈ ఫార్ములా నుంచి క్వశ్చన్స్ నెంబర్ ఆఫ్ క్వశ్చన్స్ అయితే అడుగుతున్నారండి. సో వీ హ్యావ్ అన్ ఎగ్జాంపుల్, కొన్ని ఎగ్జాంపుల్స్ కూడా సాల్వ్ చేద్దాం ఈ టాపిక్ తర్వాత. సో బిఫోర్ సాల్వింగ్ ది ఎగ్జాంపుల్స్ లెట్ us try to understand ది మాక్సిమం యాక్సలరేషన్ అండ్ మాక్సిమం వెలాసిటీ ఏ పొజిషన్లో వస్తాయి. సో మాక్సిమం వెలాసిటీ ఎక్కడ వస్తుందండి, ఆల్రెడీ ఈ వీడియో స్టార్టింగ్లోనే మనం చూసాం. ది మాక్సిమం వెలాసిటీ ఆఫ్ ఎ పార్టికల్ executing a simple harmonic motion is occurs at the mean position. That means at mean position we got it as maximum velocity. Vmax across at mean position we got it as maximum velocity. Mean position ante the point at which the displacement is zero. Mean position is the equilibrium position and displacement zero kada. So let us check for the maximum velocity formula. V equals to ఇందులో ఈ ఫార్ములాలో మనం y వాల్యూ 0 తీసుకున్నాం అనుకోండి, Vmax ఏమవుతుందండి ఈ ఫార్ములాలో y వాల్యూ 0 రైట్. సో at y is equals to 0 we got it as the maximum velocity, that is as y 0 అయితే ఈ ఫార్ములా ఏమవుతుందండి, we got it as a into omega, amplitude times of omega. So a is constant and omega is also, for a uniform circular motion, omega is also a constant. So Vmax, the formula for maximum velocity, that is amplitude into angular velocity. And for maximum acceleration, we know that maximum acceleration is occurs at the extreme position. So extreme position ఎలా డిఫైన్ చేస్తామండి, extreme position is a position at which the maximum displacement from the mean position. దాన్ని మనం అక్కడ ఆ ప్లేస్లో y displacement, maximum displacement could be the amplitude value. Acceleration occurs at extreme positions. Velocity of course 0 ఉంటుందండి extreme position దగ్గర. సో extreme positions అంటే we get the maximum displacement from the mean position, దాన్ని మనం amplitude అనుకోవచ్చు. And in this formula we get it as the maximum acceleration as minus omega times of Ymax, that as y ఏమవుతుందంటే y ఏమవుతుంది ఇక్కడ Ymax కదా, సి పొజిషన్లో y అనేది Ymax ఉంటుంది, దాన్ని మనం యాంప్లిట్యూడ్ కింద తీసుకోవచ్చు. దిస్ ఈజ్ వాట్ ద మ్యాక్సిమం యాక్సలరేషన్ ఫార్ములా. క్లియర్. సి ఈ స్లైడ్లో కనిపిస్తున్న ది డిస్ప్లేస్మెంట్, వెలాసిటీ అండ్ యాక్సలరేషన్ అట్ ఏ గివెన్ పాయింట్ దగ్గర ఆర్ అట్ మీన్ పొజిషన్ దగ్గర వెలాసిటీ మ్యాక్సిమం ఎలా ఫైండ్ అవుట్ చేయొచ్చు యూజింగ్ దిస్ ఫార్ములా. అండ్ ద ఎక్స్ట్రీమ్ పొజిషన్ దగ్గర ఆఫ్ కోర్స్ ఎక్స్ట్రీమ్ పొజిషన్ ఇస్ ఎ పొజిషన్ వేర్ ద వెలాసిటీ ఈజ్ 0. No need to find out the velocity. Extreme position మనకు కావాల్సిన acceleration using this formula you can find out it. And of course the mean position దగ్గర we got it as at the mean position the acceleration is 0. No need to find out the acceleration at the mean position. We can find out the velocity at this mean position using this formula. Clear? So entire ఈ slide లో కనిపిస్తున్న these 3 formulas and ఈ 2 formulas are very very important from the competitive examination point of view. Let us try to solve a simple question using this concept. A mass of 2k is oscillating in a simple harmonic motion as a maximum displacement of 20 mm, right? And a time period of 1.57 seconds. At time t equals to 0, the displacement is 0. Then the acceleration at a given point. We know that acceleration at a given point, that is minus omega square into y. And y we know that minus omega square into y. We know that already derivation that y is equal to a sin omega t. Clear? A sin omega t. So ఇక్కడ మనం ఫైండ్ అవుట్ చేయాల్సింది that is omega. We know that omega equals to theta by t. For one revolution the time will be time period, the theta will be 2 pi. So omega can be considered as omega by 2 pi. 2 pi by t, that is 2 into pi value 3.14 by the time period that has given 1.5 second. So 1 is 2, so we will get omega as 4 radian per second. Clear? So acceleration at a given particle, that is minus 4 square, that is 16 into amplitude, that is 20 mm, 20 by 1000 meters లో కన్వర్ట్ చేస్తే, and sin 40. Clear? 1 is 50 is of course 2 8 is 225 is. So minus 8 by 25, that is minus 0.32 sin omega t, that is sin 40 could be the acceleration at a given point using this formula. Right, for this question option A could be the right answer, right?